So, all right, welcome AP Calculus students. This was the attendance question for today. Can a function be increasing and concave down? You should have said yes, absolutely. This is definitely possible. When we think about a graph that might behave like that, so I have to draw something that's increasing. So there's a couple ways I can draw things that are increasing. But if something is concave down, we should be at the point that we could say that the second derivative is less than 0. Said another way, f prime of x is decreasing. So basically, we need something where its y value is going up, but the slope is going down. It doesn't say the slope is negative, but the slope is decreasing. F double prime is negative. So when you think about like a tangent line attached to those pieces here, let me just get rid of that. Just kind of compare these two pieces. Think tangent line. So both of these are increasing, by the way, right? Y values are going up, right? I'll make my coordinate system over here. As I go left to right, Y values go up. But on this one, F prime is increasing, right? Whatever this slope is more. This is the definition of concave up. F prime, slope of the tangent line, it's still positive, but it is decreasing. So don't mix up decreasing and negative. They are not the same. So if you said no to this, you probably confused those two pieces. So just to illustrate this a little bit further, because this is a key component here, okay? So here is a little sketch. You got a little mountain climber here. You have a point, you have a tangent line, you have some function, but nobody cares what that is. Look at this slope. So the slope at that moment is negative 268.18, which tells us that this function here is decreasing, right? Y values are going down. The Y value is positive, but it's decreasing. As I animate this, sorry, that's a little fast. Let me slow that down. Okay, so let me back him up. So as I animate this, if you look at this slope, you notice that it's increasing. Again, this is often confused by students because they look at this and they go, wait, it's negative. But as I go to the right, do you notice that the tangent line is tipping up? In other words, this number, right, like you don't care that it's negative, you care that it's moving to the right on the number line. That is the definition of an increase. Don't make it more complicated than that. Don't try to describe it as a direction or like some weird things that sometimes people describe, especially in physics, make that harder than just say it is increasing. And it's still increasing. The slope. The function, though, has changed from decreasing to increasing. So I'm going to be super picky. If you say it is increasing, therefore it's concave up, I will mark that wrong all day because I don't know what it is, right? Is it the slope of the tangent? Is it the y value of the function? Is it, I don't know what you're referring to. You can't say it. You've got to be more specific. But notice it is still this number, this slope, the tangent line is still tipping up to the right. So in this whole piece, the right side of this tipping up, tipping up, tipping up, tipping up, tipping up, still increasing, concave up, concave down. And right there is that moment, if you watch it carefully, you can see this tangent line starts to tip back. But here is the moment I was talking about in the attendance question. Notice the slope here is positive, which means the function is still going up, right? We're still walking uphill here, except the curve is flattening out. And that's the idea then of concave down. because this rate, this slope, is now decreasing. Right? It was 48 or something we saw, still decreasing. Still decreasing. And right here we're going to get a horizontal tangent. The function is now decreasing. The y values here of this function are going down. But it starts going down faster and faster. And so that's why we're still looking at a concave down scenario, right? This is still decreasing. And it just switched right there. Like the function is tipping, I'm sorry, the line here is tipping down, and now it is tipping up. So you cannot make concavity synonymous with the function increasing or decreasing. It could be either. And so don't overgeneralize that. Here's the last piece I want us to look at here. Oops, that's not good. In terms of, can I look at a graph here of f prime? So f prime, this is the derivative. Okay, I'm going to now ask questions about f. Like, where is f increasing? So if f is increasing, I'm just talking about y values going up. Okay, y values are going up if the derivative is positive. Oh, okay. So that means I really just need to look here and go, okay, so starting at this x value of -2 until this x value of 7, right? Do you notice that I have the curve here that is above? Okay, so it is actually then increasing, starting at -2 all the way to 7. We're not going to include, well, let me say it this way, that at -2, we should be able to tell if it's a min or max for f as well. And that's going to be the reason that I'm not going to include it in terms of the interval. I would probably include 7, right, because this function stops at 7, and it's increasing all the way up until 7. So f, this is f, is increasing on an interval like that. So you might be curious as to why I glossed over x equals 5. Don't need that. We get these random arc links here sometimes. So at 5, let's think about what's happening. So first, the derivative equals 0. It's the y value there, right? This is the graph of f prime, so what is f prime of 5? 0. Okay, max or min then, right? Horizontal tangent. Again, not necessarily, because do you notice here, like when we think about the table that we would make, so if 5 is a critical number, and I look at the interval before it, and then I look at the interval after it. I don't want to put that number there because I don't want to give it away yet. But and I think about a test value, and I pick a test value of like -4. So thinking in here, and wouldn't we say what f prime is doing at the test value? And don't think slope. This is f prime, so it's about 3-ish. So it's positive, which tells us that f is increasing. And then on the other side, do you notice that we're going to get an increasing here as well, because the y value, again, not slope, because this is f prime, this is slope. So therefore, this would be much more like a cubic thing happening that becomes a horizontal tangent, keeps going up. And so that's why I can use that whole interval. Also, so thinking of other critical numbers here, you would have started really making this table at -6. We're looking for where the derivative is 0 or undefined. Derivative is 0 here at -2. There is a strong temptation to put a 0 here, thinking right there, and call that a corner and say the derivative is undefined. False. Absolutely false. Remember, this is the derivative. If I say, what is f prime of 0? I hope you say 5. F prime of 0 is not undefined. So in terms of where is f prime undefined, well, it's not. Right? There's a point everywhere from -6 to 7. So my critical numbers here would be then -6 derivative, or the derivative is 0 there, but it's an endpoint. So -6. I'll probably say this. Oftentimes they'll ask for critical numbers on the open interval, so it ends up not being included. It's going to be in your test interval anyway because it's an endpoint. So let's give the critical numbers on the open because that would be really consistent with like AP and the typical questions asked. So we should really only be looking there or there. Okay. Don't look here. Don't think horizontal tangent because again, this is the derivative. If you think horizontal tangent, you're putting a tangent on the derivative. You're talking where f double prime of -4 equals 0, and you're answering now the wrong question. So finally, the last piece here. Can you tell me where f is increasing and concave down? Which was my question here in this scenario. So it's increasing. So I should be looking for f prime f prime is positive. Sorry, I didn't mean to delete that. Okay, so f prime should be bigger than 0. That will mean f is increasing. So I should be looking at those parts of the graph again. And concave down. So I want to think about, you can kind of put a pencil on the graph and think about like what happens for the slope between D and E. Well, it's always the same, right? It's a segment. So, well, that is not going to be this piece where I need to say that f prime is decreasing. That's not going to be true. In this next piece from E to F, slope, 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 f prime is bigger than 0, and that's the y value, remember? So if I say f prime is decreasing, which is f double prime is less than 0, those two are the same, so it's decreasing here to here, and the answers are going to be x's, not points. So if I would say from 0 to 5, I would write it this way. You shouldn't be looking at that point, but we're saying the x's from 0 to 5 are satisfying that. Okay. And finally, the last comment is when you're thinking about points of inflection, we'd be looking for where f double prime of x is 0, or where f double prime of x is undefined. This is really the analogy of what we were just doing with critical numbers. So f double prime is 0. I need slopes on this graph to be 0. I already identified one here, and that's the only one. So far we have a possible point of inflection at x equals -4. Also, where is f double prime undefined? Here, here, and here. They're all corners. And so I can't find the slope on f prime. F double prime is undefined. So I would have x equals -2, x equals 0, and then x equals 5. I'm going to make a table. I'm going to see, is it true? Does f prime change? I'm looking for a change from plus to minus or vice versa. If it does, point of inflection. If it doesn't, not. If you're clever, you can read it right off the graph. So, does f prime change from increasing to decreasing? If it does, then we have ourselves a point of inflection, and it does. Does f prime change from increasing to decreasing? Nope, not a point of inflection. Does f prime change from increasing to decreasing? Again, which is the same thing as saying f double prime changing from positive to negative? Yep. Does f double prime change from positive to negative? Yes, because f prime changes from decreasing to increasing in that scenario. So there's a quick summary. I hope that's helpful in answering the question, can a function be both increasing and concave down? And hopefully you can unequivocally say absolutely.